What's up? It's your chem guy, Jay. You may have heard of the collapsing drum experiment where you have a can, like a soda can, implode under atmospheric pressure. This is a fun party trick you can use to impress your friends or family and seem very smart and scientific, right? So by watching this video, I'm going to show you how to do this the right way the first time so you don't embarrass yourself, and also how to explain it. As you may have seen, I posted this on my Instagram and TikTok and YouTube Shorts. Basically, you just take a can, you heat it up in water, and you dunk it into some cold water, and you'll see a cool implosion, as you have here. As for materials, you'll need an empty soda can, preferably a few if you want to repeat it. You'll need access to water, you'll need a stove, some tongs, and you'll need a shallow dish or plate that you can fill with water enough that when you place a can upside down like this, it will totally cover the opening to the can. This is necessary for the implosion to occur. So what you're gonna do first is you're gonna take your can, you're gonna fill it with water, probably about this much, and you're gonna heat it on a stove until it starts boiling. And you're gonna see water vapor coming out of it. It's important to leave some water in the bottom of the can even after boiling, because if you don't, that means that all the water is boiled off and some air will be replacing it. And this experiment works by the water vapor condensing to liquid. So if you have some air in there, it will not create as large of a pressure difference and it might not actually implode. You also must submerge the opening of the can fully into the water like so that no air can get in around it. If air gets in and around it, it will not implode and you'll fail again, and no one wants that. So make sure you can fully place it in. The science behind this is quite simple. By boiling the water in the can, you're displacing the air inside with water vapor. When you dunk the can in cool water, the water vapor rapidly turns to its liquid state. Liquid water is 4 orders of magnitude more dense than gaseous water, so when the gas condenses, the volume occupied by the water in the can shrinks by over 1,000 times, which creates a significant pressure differential. In this process, we've created a vessel with a pressure that's significantly less than the atmospheric pressure around it. To restore the equilibrium of pressure in our system, the air wants to flow into the can, but as you may have predicted, we already blocked this outcome by submerging it fully in water. So you will have some water actually go up into the can because you're essentially forming a vacuum. But it will not go so much as to fill the entire can, still leaving a significant pressure difference. So because of that, the only other option to restore equilibrium is for the air outside the can to squeeze it so hard that it entirely crushes the can. This can be explained by the ideal gas law you may have heard if you've taken a chemistry class, but there's an inverse relationship between pressure and volume. So as you increase volume, pressure decreases, but as you decrease volume, as in this case, we're decreasing the volume of this can, the pressure inside the can will increase and therefore become closer to the pressure that is around the can and eventually restore equilibrium. So let's do it. If you enjoyed that experiment, please don't forget to like, subscribe, and follow for more videos like this. I post every week, and on my Instagram, I post daily.